Right, hello. Sorry about the obvious gap there. I am going to have to run over there to do the live demo, so I'm just going to shout from the corner. So if you'll kind of, give me some grace on that, that'd be great. As I say, I'm Jonathan Rayner, and I'm going to be talking tonight about the Apollo language server and Apollo connectors and Rover, three things that I've been working on fairly closely for the last 6 to 8 months or so. It feels a lot longer, but these things always do. I'm actually from the north of England. I'm not from around here. So if you have trouble with my accent, I've put subtitles on all the preceding slides. No, I haven't actually done that, don't worry. But it would have been quite amusing. It does remind me though, someone once told me about speaking at international conferences, and they once told me, well, they went somewhere and they had to speak for a translator. And they thought, well, this is going to be quite hard, so how am I going to make this work? And they thought, well, I've got a really good joke, I'll do that at the beginning and everything will work fine. Until they were stepping on stage and they realised, oh no, because that's a play on words in English, that's not going to work translated at all. And so they got up on stage, they tried it anyway, and everybody laughed. It was hilarious, the room was in uproar, it was brilliant. And then they thought, oh, that's great, and they kept going with their talk. And they got off stage and they went into the bar and they were chatting to their friend and they said, oh, I thought my joke went over really well. What did you think? And he was like, oh, did you not know what the translator said? And he was like, no, what did he say? He said, well, he told the joke quite quickly, and then when everyone looked a bit blank, he sort of said, and this is a very funny joke in the speaker's native language, so please laugh to make him feel welcome now. So, I hope that you give me a bit of the same welcome when I'm talking here today. But anyway, so, joking aside, who am I? Because, why am I standing on this stage? So a story in 4 pictures. So this is me on the left-hand side with my lovely wife, Lauren. We've been married for just over 7 years. We had our anniversary in June. In the middle of that is my cat, Oliver, who loves fruit bowls, trying to hunt birds, even though he's white and grass is green. He doesn't seem to understand that. I enjoy running in my spare time. That's me having done the whole 10K a couple of weeks ago, and I'm doing the Vale of York half marathon in about 6 to 8 weeks, though I haven't done much training, so it's going to be an interesting one to see how that goes. And then the bottom is the album artwork for the podcast that I run every week, which is called Look Into My Eyes, which is a retrospective on the Demon Headmaster series of TV shows and books. So if you're interested in that, come chat to me afterwards. So what's my career path been like? Because, just to give you a bit of my background. So I started off 2011, summer internship at BlackBerry. Now, BlackBerry were, if you remember 2011, it was the nadir of BlackBerry. They were the preeminent phone maker. And then this happened. And actually, interestingly enough, if you look just here at the price where the SharePoint was at the absolute lowest, that's when I joined the company. So, well, I don't know what that says about me, my ability to do things, but my dad actually sort of had the last laugh on this one because I came home after I'd been laid off from BlackBerry. And he said, well, Jonathan, you see, the problem is you just picked the wrong fruit-based phone manufacturer. And I was like, thank you, Dad, thank you. It was really, really comforting there. Anyway, so didn't let that stop me. Went back, finished my bachelor's degree, did my PhD at the University of York, started 2016. That's a picture of me wearing a shower cap, as my wife likes to point out on numerous occasions. And then joined Anaplan in 2019 and mostly worked with them on Java, or high-performance Java for their calculation engine. And then further to that, worked on large-scale testing of the Anaplan model system, essentially, and we built a lot of Rust operators to do that, provisioned our own infra. It was really, really interesting. Then moved to Monzo in 2022 and worked on their data team. We're mostly looking at data pipeline ingest for their thousands of analytics events that they have, and how you kind of package that into consumable models that people can actually use things for, like machine learning and all that kind of stuff. And then moved to Apollo in 2024. Mostly worked on Rover while I've been there, and now our team's kind of shifted focus a bit, and we're looking at how you do really large-scale GraphQL deployments. And if I can shamelessly plug an event while I'm here, if you want to see more of that, then please come along to Summit because we'll be talking much more about it there. So I'm also the chief meme officer of Apollo. This is a largely ceremonial position, but something that I quite enjoy. This is actually from our conference CKO, which is our kind of big company kickoff. And it got to the point where I was walking around the hotel we were in, and people came up to me and be like, "It's you, the meme guy." And I was like, "Okay, cool, fine. We'll just go with this." So, and also this is great. A little Slack hack for you. You can have Slack groups of 1, and you can call them whatever you like. So if you want to become any person, you can just make a Slack group of 1, add yourself to it, and call it whatever you like. So, little hack for you there if you want one. Anyway, so moving on, aside from me and who I am. So what we're going to talk about today is a couple of different kind of Apollo-y concepts. So things like Rover, our CLI, federation and connectors. I won't spend too long talking about what federation is, because I guess in this audience probably a fair few people are going to understand, but I'll at least try and talk about how connectors fits into that in an interesting way. And then how we brought together a kind of confluence of technologies, so Rover Dev, one piece of Rover, connectors, and the Apollo language server, to make a really interesting development experience for connectors and for GraphQL in general. I'll talk a bit about refactoring Rover, and then I'm going to do a demo of the language server running live. Knowing my luck, the floor will cave in or the roof will explode, I don't know. But anyway, demos never go my way, so we'll see how this one goes as well. Anyway, so this is Rover. This is kind of our concept art when we were trying to kind of give Rover a personality. But Rover is the Apollo CLI, and it is essentially the way that you interact with most of the Apollo system. So you can do things like you can publish supergraphs through it, you can compose supergraphs through it, you can publish subgraphs, you can introspect your graphs. Basically anything you can do with Apollo Studio or the platform API you can do via the Apollo CLI is the principle. And chiefly important for us is that Rover has a function called Rover Dev, and Rover Dev is essentially a way of saying, what if I were to simulate running a supergraph but just on my laptop with locally running subgraphs? And you'll see why that comes to be important in a couple of minutes. So federation, the promise of connectors. Now, as I said, I don't really have to spend a huge amount of time explaining what federation is for many important reasons, but just in case anyone doesn't know, federation is essentially a way of taking multiple subgraphs and giving yourself a single endpoint that you can use, which then does the API orchestration of working out which of your subgraphs it needs to talk to. So essentially, you can have multiple different subgraphs that correspond to multiple different APIs in one endpoint. And the promise of connectors is, what if we could bring REST APIs into that as well? So you could have REST APIs as GraphQL entities, effectively. And they would look like GraphQL, they would behave in some ways like GraphQL, but they would still be REST underneath. And so how would you actually go about doing that? And so that was the elevator pitch for connectors. And this is actually what it looks like. So it basically has two directives. You have a source directive here, and then a connect directive. And the source directive is basically just saying, where is the REST API that you want me to be able to hit? And so it's at some URL. And then the important part is this selections bit here. And essentially what this is saying is, take the things in this products list and map these parts of it into this GraphQL product object. And that's essentially kind of the concept, is you're using selections to map things into GraphQL objects. And so what this means is you can pull out different parts of the REST response and make them into something that looks more like GraphQL. And so with just these two directives, you can make that work for REST APIs and bring them onto the graph as though they were almost GraphQL, with some limitations, but essentially the concept. So Rover Dev. So one of the things we thought was, well, we're going to need some better dev tools for this, because you can't just give a selection mapping language and expect people to kind of make it work. And so we started casting around for, well, what dev tools do we already have? And so we came across Rover Dev that I mentioned before. And so this is kind of a schematic idea of how Rover Dev works. You take a supergraph YAML file, which is essentially a description of a load of subgraphs. This is what the name of them are, and this is where you can find them. And then from that, Rover works out where the GraphQL schemas are, and actually the implementations as well, but the schema is the important bit in this case. And it listens to any changes that are made to those schema. It then composes those schema into a supergraph and passes that to the router. And all of this is running inside of Rover Dev's purview. So it knows about the router, it knows how to compose, and it knows how to listen to these GraphQL schema. And if you look at this and kind of squint slightly and look sideways a bit, it looks a lot like a language server. Because language servers are essentially taking code files, they're listening to changes, they use the compiler or static analysis. That's where it gets a bit fuzzy, but for the sake of analogy, we'll leave it like that. And then you pass hints and outputs to the IDE so that you can make changes to your code as you go along. And so we thought, well, what if we took the parts of Rover that we had, the sort of composition in a loop elements, where you're listening for changes in schema and you're recomposing, and then we reused them as a language server. And that's essentially the concept that we came up with. What if we took Rover Dev and we took something that knew how to talk to IDEs, in this case the Apollo language server, we could then produce a language server that would help you to build connectors, and actually GraphQL as well, because you could have all the knowledge of GraphQL schemas inside of it. And so that was essentially the idea. And this was pitched to us as the Rover team, and we said, well, I mean, that's going to be quite hard for a lot of reasons, but it seems doable. And it seems doable mostly because that central element, that kind of composition in a loop idea, is something that actually a lot of different teams were asking us for in different forms. So how do we go about refactoring Rover Dev? Well, this is essentially the design that we came up with. So it's quite similar to what we saw before, but the important part is that this bit on the left is the composition in the loop part I was talking about. And this is fairly similar to what we had before, with the important difference that we now have to listen to changes from the supergraph YAML, not just from GraphQL schema. And then on the right-hand side over there, we have this broadcast channel. So we send successful compositions, or even failed ones, in fact, to the broadcast channel, and then we can push those events out to anything that wants to listen to them. So it might be a router, it might be a language server, or anything else that we might want to put on the other side of that broadcast channel. And so this is kind of the design we came up with, but there's quite a few problems with trying to implement a design like this. As nice as it looks in theory, in practice the code is not like this. And so one of the problems with that is that Rover is designed in a very particular way, or was designed in a very particular way, in that it was designed to work in a kind of leader-follower way. So when Rover boots up for the first time, if you want it to run in this Rover dev mode, it tries to grab a system port. And if it can grab it, it becomes the leader. And then all of the other ones, when they fail, they become followers and send messages to the system port instead. And so the idea was that you could have multiple Rover dev terminals running with multiple subgraphs in each, but all of them would form this supergraph eventually. That was the idea. Now the problem with that is that it doesn't really make any sense to do that in the context of an IDE, because why would you have multiple instances of the thing running? It doesn't really make any sense. But the problem with that is that this is so inbuilt into how Rover works that taking this out requires you to kind of split apart things that are kind of almost indivisible from its perspective. So what we ended up with was actually having to re-engineer almost the entirety of how Rover dev works using an asynchronous Rust runtime, and then coming up with new concepts like this is how tasks work, this is how you can represent a subgraph as a task, this is how you can communicate between tasks, and so on and so forth. So this was a huge part of why this was so difficult, was because leader-follower was really embedded deep into how Rover wants to work. The second part is monitoring the supergraph YAML, because previously with Rover dev, you only have the supergraph YAML was very much considered as a static object. You read it in when you started up, and you never did anything else with it. But that's a really terrible experience when you're trying to work on a language server, because you don't want to have to be restarting the language server every 5 minutes when you're making changes here. So the idea was, well, what if we changed one of these things? We get the file change event. How can we react to that? And the most interesting one was changing a federation version, because when that changes, it requires a whole new composition binary, or potentially anyway. So you have to do things like throw away all of the old versions that you're working with, get the new ones, recompose, all of that kind of thing. And so this was probably the second biggest challenge in the whole thing, because Rover dev was never made to monitor YAML files. It was always made to monitor schema, and so they're always supposed to be being composed, and this isn't. And so again, you're having to think of a whole new way of bringing events into the event loop, not just kind of having them already there from schema. And the third part is just, how do you break down a monolith in general terms? Rover dev is this idea that kind of everything is contained within itself, and it's a very complicated system because it has to listen to files, it has to listen to things on the web, it has to listen to Studio and Author Studio, and there's so many complications around how you architect something like that because it's so big and has so many pieces. So we were doing this in Rust, so we use a lot of things like Tower and all that kind of stuff. And if you want me to talk more about that, then feel free to grab me after this, because I will go on for a long time about how we could do that, but that may not be the most interesting thing for this talk in specific. Oh, that's a right click. No. Hey, no, that's backwards. Here we go. Right, so now I'm going to attempt to do this live demo. So let's see how this works. So the way that this works is that we've exposed the functionality inside of VS Code. Is that visible to everybody? Or do you want me to make it bigger? Yeah, I was going to say. No worries. Oh, come on. That's what I guessed, but I could never be sure. Right, is that better? Perfect, excellent. Right. So as you can see here, at the top we've got the source directive, and then we've got the connect directive at the bottom. So if we just have a look at what this API is actually giving back, if we go into here, featured listening. Oh, I have no internet. That's going to be exciting. Anyway, what that would have shown you is that API is just giving back. That API is just giving back essentially a set of listings, a big list of data that you can pull things out of. And so what you can do with the connectors mapping language is this kind of thing, where you can say, okay, so I want to have an ID field. I'm going to have an ID field that's called ID. I'm going to have a title field that's called title, and I'm going to have this beds field, which is mapped from this num of beds field. And this is quite simplistic, what you can do here. But this mapping language and the connect directive itself is evolving all of the time. And so what you can actually do now is you can do things like you can do remapping of arrays, you can do object transformations, you can do all sorts of different things to change how the REST response comes back and how you represent it as GraphQL. And so the exciting thing with the language server is if I do something like this, I say tie is equal to a title and save, you can see here that we start getting hints from the language server at the bottom saying, oh, I don't know what this field is that you're talking about. And so this helps you to start correcting what's going on. So if we then put it back, we see that disappears. So the language server is doing this dynamically. It's composing it live and then bringing it back again so that you can see the changes that you're making. And you may well say, well, okay, that's, this is a very simple example, but can you do anything more complicated? And the answer is yes. Because what you can do is if we look at something like this. So this is an API this is the space devs, which is used fairly commonly in some of these examples. But this is an example of an API where it's always exposed as REST. But you can actually use the connectors mapping language to turn this into something that will be GraphQL based. And so, as you can see, if we look at the problems pages, so you can see here that it's already started, even though this is a kind of an open source repository, it's started to flag these different elements as being being broken in some way, so you can start to use it to fix it. Now, obviously, these files are kind of, hundreds of lines long in the mapping because this is quite a complicated API. But the exciting thing is that if you look at what this is actually doing, and if you start to feed in the connector spec to it, you can actually imagine how you could start to use things like LLMs to generate these connectors files for you. So if you had anything that was even something that's relatively complicated, you could probably give an API schema to an LLM and say, hey, can you split me a connector out the other side? And that wouldn't be impossible to do. So one of the things that we're looking at the moment is that we have the community connectors GitHub repo, which I would show you, but for the lack of internet. So you can all imagine it in your heads, and I'm sure it'll be fine. But the idea behind that is that essentially we can utilize, there it is. Oop. The idea behind that is that essentially we can utilize the kind of knowledge in the community to be able to, create connectors for really common APIs. So at the moment we have like the Stripe API is a thing that exists as a connector. There's also the OpenAI connector exists. So if you want to just get started with this and just try it out, go onto the community connectors, download one, try and run it and see what happens. Or if you have an API that you want to turn into a connector and get onto GraphQL, have a go and submit it to the connectors repository and see what happens. The whole idea behind it is that we want to build a library of these things so that we can bring REST APIs onto the graph in a really sensible way. And so that's a sort of demo of a language server working, essentially. I'm kind of showing you how it works. So that's kind of most of what I have. We've kind of been through Rover and we've been through Federation and connectors. I've shown you a little bit of the kind of confluence of technologies and how we kind of brought this out of the ether into a way to make DevX better. And then how we refactored Rover and a bit of a demo of a language server. So that's kind of a rough idea of how we took Rover, how we took the language server, smashed them together, and then made something that could actually support connectors as it launched. And so thank you very much for listening. I've been Jonathan Moran. I hope that was exciting.